Hello! Welcome to section 4. I believe this is going to be our last section. Types of metamorphism. So there's a few different ways in rocks, in which rocks can experience high heat and pressure and be metamorphosed. So there's 4 common types of metamorphism. Contact metamorphism, regional metamorphism, burial metamorphism, and shock metamorphism. Let's go through each of those. Contact metamorphism happens at a small scale, and it's actually something that you've been introduced to already. This type of metamorphism occurs when rock is heated and or chemically changed because it is adjacent next to some intruded body of hot magma. You kind of played around with this idea of the zone of metamorphism, which was contact metamorphism, when you were looking at those stratigraphic sequences, put it from oldest to youngest, and the little stars and the little things. So that indicated contact metamorphism. So some igneous magma hot body intruded into some rock layers, and on the edges of that intruded igneous rock body, it had altered, changed that surrounding rock. But really, only very close and what came in contact with that hot intruded magma. So that's why it happens on a very small scale. The intrusion of magma is surrounded by what's called an areole of altered rock. So here's an example. Let's say you have some limestone, which is a sedimentary rock, formed in the shallow depths of the ocean from microscopic skeletons of dead oceanic organisms. So you have some this chemicals or sometimes biogenic sedimentary rock limestone, and you get some granitic magma kind of bubbling its way up. Well, on the edges of that, it's going to morph, change the rock. So the existing limestone is a protolith parent rock to marble. So in contact with that intrusion, the limestone very near to that intrusion will become marble. In between the metamorphosed rock and the magma itself, you get some other chemicals leaching out of the rock to create some other weird things. But again, the limestone turns into, in this case, marble. It doesn't have to be limestone and marble. This is just an example. But again, it only happens very close to where that intrusion occurs with a matter of feet, 10 feet, 100 feet, some around there, depending on how big the magma intrusion is, how hot it is. So again, thinking back to all the different types of, and this is something we talked about in unit, 2 units ago, unit 6 on igneous rocks. These igneous intrusions, you would get contact metamorphism just on the edges of all of these intrusions as they kind of intrude into these areas, changing the existing rock, which we call country rock or native rock. Here's an awesome example. Here are this is the Grand Canyon in a section. You can see some sedimentary layers, and all of a sudden you see this kind of dark black diagonal streak of material that's definitely different than the existing red sedimentary rock. This is a igneous dike because it has a vertical direction to it, so dikes are kind of more vertical direction. And you can see just above it, this purplish stuff. So you got kind of a gray-black dike, a reddish surrounding material, sandstone. But this sandstone looks like it's been turned purple just above, and you can see just below this intrusion, that sandstone has been turned to quartzite. So yeah, just above and below. Oh, there you go, quartzite. This red sandstone turned into red quartzite. Then we have regional metamorphism. So this happens on a large scale. Contact metamorphism is only very, very close to intruded magma. This is a type of metamorphism of a whole extensive area of crust. It's associated with plate convergence, collisions, subductions. This is the type of metamorphism we see in some orogens, which are mountain building events. So, you know, when convergent boundary, when things kind of get crumpled up and there's a lot of pressure going on there, that can create this regional metamorphism. And this isn't just in a couple feet. This could be miles of metamorphism that have occurred. Regional metamorphism, you can almost think of like a whole mountain range exhibiting this kind of stuff. So you see the Grand Tetons metamorphic rocks. You see the western Sierra Nevadas, kind of this magmatic texture. These are whole mountains that you see magmatite, made of magmatite or gneiss, higher grade metamorphism. So regional, again, associated with higher grade metamorphism. You get burial metamorphism, which is the third common type. It occurs just below or after the region of diagenesis, so just a little bit more heat, just a little bit more pressure from where sedimentary rocks are created, diagenesis, as a result but it's still the same process. The way sedimentary rocks form, again, you're kind of building up this layers of sediment, and this stuff below gets compressed because of the weight of everything on top. Well, you build more and more sediment. The very bottom stuff is going to start to metamorphose, but you'll still get sedimentary rocks up until a point. So just below that area of diagenesis, so in very deep basins of where kind of sediment kind of gets deposited. To talk about burial metamorphism, which happens underneath a bunch of sediment, let's go to the exact opposite of that, the top of the world in Mount Everest. So, on Mount Everest, if you were ever to climb Mount Everest, this is from the north side, looking south from China, which you don't usually see this side, I believe. But there's this yellow streak of material, and the hikers of Mount Everest call it the yellow band. All right, the yellow band. So it's a dangerous place, a treacherous place to hike through. But you can kind of see it looks different from this material below and this material above. Well, this yellow band here, that you can see the yellow band of Everest, is marble. It's marble. So here's a little slice of it. So you take limestone, which forms burial-wise, kind of in the shallows of the ocean, and now this material is all the way close to the roof of the earth. Plate tectonics. Old rock, it gets crashed together, gets uplifted. Plate tectonics. Fun stuff. Another good example of burial metamorphism, now a mountain range. Four Peaks. Four Peaks. If you're here in the Phoenix area and you look off to the east, you'll see Four Peaks kind of off to the east. If not, you probably see it every day. You probably stare at it 1,000 times every day, especially if you're driving around. It's right at the bottom of your license plate. That's the Four Peaks. That's them. That's them right here. Hello, Four Peaks. So what you have here is quartzite, in this case due to burial metamorphism, sandstone in this case that was buried, altered to quartzite. So again, we saw quartzite in the Grand Canyon. That was contact on a small scale. This is a much bigger scale due to burial metamorphism, and now it's been lifted up. And then finally we have shock metamorphism. This occurs primarily at sites of meteorite impacts. So not necessarily, in a big scale. So you do get high heat and high pressure generated by impacts. Right? I mean, that's a lot of pressure. I can feel my hand warming up from those impacts. So you do generate high heat and pressure in a very close area around impact sites. The area underneath an impact site deforms and kind of altering some of the minerals typically in rocks. Not necessarily the rocks themselves, but the minerals in rocks. But if you're changing the minerals in rocks, then you don't have the same exact rocks anymore. So shock metamorphism, again, primarily near impact sites. Here you'll kind of hear more about this in the assignment, but also here is an awesome video on kind of just the types of metamorphism that will really also help with the assignment you'll have for this upcoming assignment. So make sure you watch that. Here's an example of what it might look like with shock metamorphism. So you get some projectile, a meteorite, asteroid type thing, hits the Earth. The area closest in contact with that projectile, that impactor, will melt. High heat and high pressure. But as you get further away, you create shock metamorphism. The high pressure with some heat alters mineralogical alters the mineralogy of rocks. Some of those minerals change to different minerals, therefore you're creating also different rocks in this area of shock metamorphism. As you get further out, you don't necessarily change the rocks, but you do fracture and break them up, and you can create new sedimentary rocks called breccia. In any case, great example right here in Arizona, Barringer Crater. Again, you'll hear a little bit about this in the assignment. As well, remember that the meteorite from Barringer Crater, Canyon Diablo meteorite, is what we first helped date the age of the Earth. We're able to date the iron meteorite to help us zero in on that 4.54 billion year old age of Earth. So some altered minerals that you find only impact sites can be things like coesite and stishovite. These are altered. You take the mineral quartz, which makes up a lot of the surrounding sandstone layers of rock here. You take the mineral quartz and you shock it. You change it to a coesite or stishovite. By changing the minerals, you're changing the rocks. You are creating metamorphism. And that wraps it up. So that wraps up the rock cycle, my friends. So we've talked about metamorphism and metamorphic rocks. A little too much heat and pressure, we start to melt, and now we're back in the realm of igneous, with magma cooling, crystallizing below ground as intrusive igneous rocks, or if it exits the earth as lava to create extrusive igneous rocks, breaking down, weathering, erosion, deposition, compaction, cementation, lithification, sedimentary rocks, more heat, more pressure, metamorphic rocks. The cycle goes on and on and on and on and on and on and on. Well, that brings us to the end. So what are some of those big or main ideas as it pertains to metamorphism? Well, just the grades of metamorphism, low versus high grade metamorphism back in section 1, and your ability to kind of read that chart. Certain characters, certain temperatures, pressures, or depths below the earth, what kind of metamorphism might occur. The types of textures, remember those are slaty cleavage, schistosity, mineral banding, and magmatic. On that table in section 3, the protolith parent rocks of some of the different metamorphic rocks. And the different types of metamorphism: contact, regional, burial, shock. Well, that brings us to the end. Yeah, I don't really think there's anything else I have to say. Until next time, have a good one. Bye-bye.